Okay, welcome back. We're going to continue section 8.3. This time we're talking about Celsius and Fahrenheit. So converting between those two is not quite as easy as it is between the base units. And the other parts that we've done up to this point, we were able just to move our decimal point because they were all base 10, and it was just a matter of how many zeros was different in it. So we can move our decimal point. Not so in Celsius and Fahrenheit. It's not direct conversion like that. We have a formula. Just to get our mind around kind of some common temperatures to get going with this, there's a chart. I'm on page, what page am I on? I'm on page 457. There's a chart there to kind of help you. And so I've copied some of those down, like 0 Fahrenheit, really, really cold, miserable cold, I would call that, would be negative 18 degrees in Celsius. A 0 Celsius, that's the freezing point in Celsius. By the way, it's called a centigrade scale because it's based on centa, based on 100. If you think about the prefix centa, it meant 100. So a centigrade scale, 0 is their freezing in Celsius, and 100 is boiling. So between freezing to boiling, there's 100 of those degrees. So a 0 would be our freezing, 32 in the Old English system. 10 Celsius would be 50, a little more tolerable. 20 Celsius is 68 degrees. 30 Celsius, we're in a nice warm day there. And then 100 Celsius, there's others, but 100 Celsius would be our boiling. That's the boiling for Celsius. 212 in the Old English system is boiling for us. All right, so like I said, it's no direct, easy formula here. So here's the two formulas that you can use. They're really the same formula from what we've learned in algebra. We could throw the 32 across the line, then make minus 32, and then times by 5 ninths to get rid of the fraction. So this formula is this formula. It's just rearranged in terms of C. So you wouldn't absolutely need both formulas, but if you don't want to have to do the algebra to convert it, you want to write both of those down and have those to do your work. So if you're going to convert from Celsius, say I put in 0 Celsius, 0 for C times 9/5 would be 0 plus 32. Fahrenheit is 32, right? If I put in 10 for Celsius, okay, that one doesn't work out too bad either. 9/5 times 10 for C. You could do that on your calculator. 9/5 times 10 would be 18. 18 plus 32. That is 50. So you can see that we could use this to convert each one of these. Plugging in 20, 9/5 times 20 plus 32 gives me the 68, and so on and so forth. So that's how you drop in the Celsius for C, times it by 9/5 plus 32, it throws out that number. Vice versa, if you want to go from a Fahrenheit back to a Celsius, you plug in F into this formula, and you could plug it in here, like I said, but you have to do a little algebra. But say I plug in 212 for this F, let's look at it. That'd be 5 knots. Plug in F is 212. Now keep in mind, it should be 100. Let's see if this works. It'd be bad if it doesn't, right? That'd be 5 knots. 212 minus 32, let's see, what is that? That'd be 180. And then this would reduce. Again, you don't have to do it by hand. You can use your calculator. 5 knots times 180. But by hand, I'd put that over 1. 9 would cancel into 180 20 times. 5 times 20, there's the 100. And then Celsius equals the answer. So there it is in Celsius. So that's how you go back and forth between those two. Well, they don't always work out just perfectly. Sometimes we'll have a decimal. Like these were the nice ones. But let's say we wanted to know 25 degrees Celsius. Let's see how that one works out. Let's do 21 degrees Celsius. So that one's not going to come out as perfectly. So whenever we plug in 21 for Celsius, we're going to use this formula. F will be 9/5 times 21 for C plus 32. Well, see, this time 9/5 times 21 is a decimal, or a fraction if you wanted to be more exact. But we'll go ahead and use decimals in this. I know sometimes we stick with the fractions. They're a more accurate answer. But in this case, a decimal will be acceptable. When you take 9/5 times 21 over 1, notice 5 and 21 do not reduce perfectly, and that's why I'm getting this decimal. I'm going to have, and again, I just encourage you to use your calculator to do this, but so I'm going to pick up my calculator. I do 9 fraction 5 9/5 times 21. and that's 37.8. And sometimes it's even a repeating decimal, so you have some round off errors, so do watch the directions and see what they say to round to. This one had a terminating decimal, so that was kind of better. And then I still got to add 32, so then plus 32 equals. There's almost that perfect temperature in your house, right? The 70 degrees. It's right at it, 69.8. So right at 21 degrees Celsius is kind of what a lot of people consider to be a comfortable temperature in your house. All right, let's do a couple more of those. On page 458, again, if you're following along, on page 458, example 5. So this one, it says if the temperature outdoors is 28 degrees Celsius, what is that in Fahrenheit? So if Celsius is 28 degrees, 28 Celsius, I guess that's redundant, what is that in Fahrenheit? So convert it. So if we have C, we want to use this formula. Again, you can use either one, but this one will be arithmetic and you won't have to do the algebra. So plug in the 28 for C, and Fahrenheit's will be 9/5, C is 28, plus 32. Again, this one's not going to come out quite as slick because 5 doesn't go into 28 evenly, so it creates a decimal or a fraction. So I'll pick up my calculator there, do 9 divided by 5, or 9 fraction 5, times the 28, and then plus 32, you're going to get 82.4. That's what I consider a comfortable temperature. I like it a little bit warmer. So 82.4 degrees would be rounded to the nearest 10th place, and this one didn't have too much rounding anyway. All right, the other thing I would draw your attention to in section 8.3 is page 459. This is just an interesting little chart that shows the year that people officially adopted the metric system. And you'll notice that we have not done that yet. So we're not on that list. We're still, we use the metric system for many things, like our liter of pop. Obviously, the bottling company has moved us over to the metric system. We've been comfortable with that for years. We use quite a bit of the metric system in the medical field, and if you buy tools for, there's metric tools and then there's the customary tools. So we use a lot of the metric system, but it's certainly not our official measurement yet. We have not adopted that. So if you'll look on page 459, there's a chart that says France adopted the metric system in 1795. Belgium, 1820. All kinds of countries. Britain, 1965, so they're a little bit later there. Ireland, 1967. Jamaica, 1998, and that's as far as that chart goes. I don't know if there's been an update in that since this was published, but just notice we're not on there. There's actually only a couple countries in the whole world that do not have the metric system adopted, which makes this kind of unique. It says almost every country in the world except the United States, Liberia, and Myanmar, if I said that right, that presently use the metric system. 3, I think I said 2, but there's 3 of us in the whole world, the whole world that is still holding on to some of our customary units. But like I said, we use the metric system, so it's not like we're not aware of it. But I didn't know if you knew that we're kind of unique in that way. All right, so that concludes section 8.3. I'll join you again in a minute for section 8.4.